We present a multi-view 3D object detector with transformer and pixel-aligned recurrent queries. This is our architecture. Next, we will introduce our pipeline step by step. In this work, we tackle 3D object detection from a short video snippet, for example 3 views. We first extract the image features using a CNN. Then we generate the appearance and geometry-informed queries. We randomly generate a set of reference points in the 3D space bounding a large region of the view frustum. Take one reference point as an example. We project this point back to 2D input views and bilinearly sample the feature vectors at the 2D pixel locations. We aggregate the feature vectors across all views with average pooling. We also encode the 3D location of the reference point with the Fourier positional encoding, followed by a small neural net. By encoding the 3D location of the reference point and its appearance from the input views, the query carries both appearance and geometric cues and allows the model to encode 3D to 2D correspondences and make 3D predictions from just 2D input views. Initially, the reference point is far from the object, as it is randomly sampled from the 3D space. We perform a few iterative predictions via recurrent decoding. Our decoder chains a single transformer decoder layer and a detection head. In each iteration, the transformer decoder takes the query and input feature maps as input to capture long-range cues. The detection head inputs the output of the transformer decoder and makes 3D predictions. We predict the relative offset of the object center from the reference points and other 3D bounding box parameters. In the next iteration, we encode the newly predicted object location and its appearance in the query of the subsequent update. We decode this new query using our transformer decoder and detection head. Note that all updates share the same weights in the transformer decoder and detection head. After all updates, we can get the final output. The goal of the decoder is to predict how a 3D reference point, encoded by the query, should be translated in order to match a true object center in 2D. We show the feature map instead of RGB image here. Next, we gonna show some qualitative results on ScanNet. The white boxes are the ground truth and the boxes with other colors are predictions. We can see some failure cases here. Our approach is prone to failure when detecting large objects, for example, the bookshelf in the current scene. In the final part, we visualize the attention map between queries and multi-view images. The red marker represents the projected 3D point. During the recurrent updates, the 3D point approaches the region with high attention weights. Thank you for watching.